Wouldn't inventory be easier if silo walls were transparent? Unfortunately, they're not. And since you don't have Superman's X-ray vision, you need another way to measure the material in silos. Having an accurate picture of your inventory is a big deal. Consider the safety implications of having to check levels by climbing silos. According to OSHA, falls are the #1 cause of death on the job, and lack of fall protection training, along with improper ladder use, were among the top 10 most cited OSHA violations last year. Many companies are desperate for solutions that can utilize technology like sensors and software to prevent injuries and enhance efficiency. Besides the safety component, high-tech solutions bring accuracy and, with that, cost savings. In fact, one facility found switching from a manual process saved them more than $200,000 in safety stock and another $11,000 in labor costs. So how do you know how much inventory you have without climbing the silo? Well, today we're joined by Scott Hudson of Binmaster, who will share some of the best practices and latest technology for monitoring silo inventory. Additionally, Scott will showcase a common example of how plants are using level sensors and software to make their operations safer and more efficient. Scott, you've pretty much heard it all when it comes to measuring what's inside of silos. What kind of mistakes do you see processors making when it comes to managing their inventory?
I think one of the biggest mistakes we see is people not thinking long-term, looking at the short-term cost of the equipment and not thinking what are they going to actually do with the data long-term, how they're going to use it, how they're going to process it, and then how they will manage their inventory with it. And so sometimes they are trying to look at a very cheap device when in the long term they would probably get better off with something that costs a little bit more and gets them the data they need and the information they need to manage their business.
Well, what are the most common types of level sensors used in silos?
There are two basic types of level sensors that are used in most silos, and those are point level and continuous level measurement devices. Point level will measure at a single point within the silo. That might be the high level or the low level. So you can think of that as an on-off device. So when you get to those levels, whether it be the high level or low level, the sensor will go off. And then the other type is a continuous level measurement. And that's going to take inventory measurements all the time. And you're going to get inventory levels on a continuous basis, and you'll see the data on a continuous basis. And that's the two basic types of level measurements you'll see in silos.
Tell us about which sensors are the most popular right now and why.
So as far as what's popular right now, as far as total volume goes, our rotary paddle sensor is our #1 seller, but most people are starting to look at continuous level devices, and that right now is a non-contact radar. We kind of see that as almost a silver bullet inside the industry. It can be applied in most bulk level measurement applications and work almost flawlessly. We very rarely have found a situation where the non-contact radar doesn't work.
Are you seeing any specific trends when it comes to silo monitoring?
As mentioned before, the non-contact radar seems to be the trend. This technology about 4 or 5 years ago really was troublesome, and a lot of people tried it and it didn't work the way they had hoped. They'd have problems out in the field. They wouldn't get the readings they'd want. They'd have misreadings. But that technology has changed quite a bit. We went from a 26 gigahertz radar to an 80 gigahertz radar in the last few years. We've been applying that in a lot of silos, and that particular technology has just proven itself to be very, very accurate and give us the readings we want. And so we've seen a lot of people adopt this technology and put it into their silos. So additional things that we're seeing trending in level monitoring is just 24/7 access to the data. We see a lot of people in the past that have kind of been hesitant to adopt this technology have really come on board with it. We see the trend being that people want to go out and do their daily lives, out with their kids, out with their friends, and still be able to be connected back to the plant, back to the silo, and be able to read that information. So monitoring 24/7 has been a big trend in the last couple of years.
Okay, tell us a little bit more about local monitoring within the plant. How is that being addressed?
What a lot of people are doing with local monitoring is they're using local displays. We use our digital panel meters to accomplish that. This is just a small device that can be put into a panel, or we can provide a panel with them that takes the sensor data and displays it in an electronic format. And in this case, we have digits that are displayed. This gives them instantaneous feedback on what their sensor level is. And so they don't have to wait for it. They can make their decisions right there and then. And generally speaking, these are put at the base of the silo or back in the control room. So again, they can have that instantaneous feedback.
Let's talk about this technology from a cost standpoint. What kind of ranges are we looking at here in terms of price?
We have three basic levels. We have our smart bob, which is kind of the entry level. We have the non-contact radar, which is kind of our mid level. And then we have the 3D scanner, which is our high level. And with each one of those, the technology bumps up a little bit. You can see in the background behind me, the smart bob is to my left, the 3D scanners to my right, and the NCR80 non-contact radar is right behind me. The smart bob will start out from about $1,800 to $2,000. It is a mechanical device, but it still gets you a single continuous measurement from the smart bob. The non-contact radar right behind me, that'll start about $2,000 and go to about $3,000 depending on how you set up the sensor. The nice thing about that, as I mentioned before, is it's kind of our silver bullet right now. It can be applied into a lot of bulk solids measurements, and we rarely see any problems with it. You don't have to worry about dust buildup. Smart bob, you do have to maintain it. It's an electromechanical device where the non-contact radar is completely electronic and you don't have to do anything with it. And then kind of at the high end is our 3D scanner. It's an acoustic scanner. The difference between that and say both the non-contact radar and the smart bob is that it is taking multiple measurement points from the inside the silo. Both the non-contact radar and the smart bob will just go down one direction, take a reading, and come back up, where the 3D scanner will hit multiple points and give you a 3D representation of what's in the silo. So along with that high level of technology does come a higher price, and you'll be somewhere between $4,000 and $8,000 for the 3D scanner.
Can you tell us a little bit more about the software component that is associated with this technology?
We're seeing a lot of trends with BinView, which is our in-cloud software. We're doing a lot of updates and development for it. We should have a new version of it, BinView 2.0, in January. BinView really lets you see your data 24/7 on any device that you want to see it on. We are right now in development of the 2.0 version, and that will also come with us making specific market segment type versions of it. So ResinView is a prime example of this, where we're developing the software to be specific to plastic resin silos. And in that, we will develop the software to show the data and the trends and the information that the plastic resin market needs versus just being general. BinView is great for a general application, and if you just have a typical application, it'll be great for you. But we really want to market and develop our software to target these niche markets such as resin, concrete, even wood, a lot of different areas. And that's going to be the trend that we see going forward, is that we will develop software to apply to those markets, give them the information that's specific to them, and give them the trends and data that they need.
Scott, can you give us a quick example of how this system would look?
Sure. One of the things that we've noticed is that systems have become a much bigger component of what we do at Binmaster. In the past, a lot of times people would just buy a sensor and then they would figure out how to install it, set it up themselves, and get the data to where they needed it, whether that's in BinView in the cloud, Binventory on the local network, or just on one of our digital panel meters so they can see it locally. And so what we've developed is a couple different systems to use that data. Right now, I'm going to show some a nice example of our wireless system, which uses multiple components, including the digital panel meters, our NCR80, and getting it out to BinView. And here you can see we start with just a sensor and the wireless transceiver, sending the data out to a base station, our WR90BA. And in this case, it happens to be a 4-to-20 unit, and it's got a single connection to the wireless unit, sending it over to the base station. But we can expand on that and add additional units. So we have additional 4-to-20 units, as you can see here, transmitting back to the base station. But it doesn't have to necessarily be 4-to-20 units. It could be a Modbus units, and that's what you can see right here. We have a Modbus daisy chain running back to our wireless WR90 transmitter, and it's transmitting back to the base station. And as you can see in this system, you can see that we use both 4-to-20 units and Modbus units, and that's something we can bring to the table. This doesn't even have to be Binmaster sensors. This could be sensors out in the field that you have already. So we could be installing new Binmaster NCR80s, and you might have a few other sensors out there, and we can bring that data back, whether it's 4-to-20 or Modbus, back to our WR90 base station. And then we go from there where we take that information out of the base station and we can actually display it locally in a DPM, our digital panel meter. So we could have multiple units in a panel or just a single unit. A single unit can display up to 16 sensors on one DPM. So if a customer just needs to get the data back and see it locally, we have our DPM offering with this system. And then we can expand it out from there where we take the data, whether it goes through a DPM or not, it can go into a gateway. And from there, the gateway can send it out to the cloud via either cellular or Ethernet connection. And then you get the data in our BinView system, which you can access 24/7 wherever you need it. Additionally, what you can also do is you can connect it to your PLC. And data from that will go right into your PLC. We can use 4-20 or we can use Modbus. This picture is showing it as coming out of the unit, out of our base station using 4-20, but we can also just use Modbus if that's the only thing you're sending the data to. You can see overall this is a really complete system that gives you a lot of different components and a lot of different options, especially with the wireless. One of the nice things about wireless is that it really brings down the installation cost. You don't have to run the wire from the sensor all the way back to the control room, and that can cost thousands and thousands of dollars.
Scott, how does installation actually impact the cost of a system like this?
Sure, installation is a real big component of installing a sensor. Many times the installation cost will be as much or more than the actual cost of the sensor. So anything you can do to drive down that installation cost will make the project overall much more cost effective. So we have a lot of different things to help with that. We have Modbus units, which as opposed to 4-20 units can be daisy chained together. So you only have to run one wire back if you're wiring it. If you don't want to wire it all, we have a lot of our wireless systems to bring the data back wirelessly. So you don't even have to install that wire back to the control room. And then we also do things like our mounting plates, our accessories that really make installation of the sensor itself really simple and easy. We have bin disks to help set up our NCR80s and configure them so that they're very quick and easily installed and then set up to make sure they're functioning the way they should. We have a lot of accessories to help with that. One of the things I think we pride ourselves on is being able to help our customers install the units faster than a lot of our competition can.
Can you give us a little bit more detail on how the wireless modules work?
As you saw on the slide earlier, the wireless modules work by taking the sensor output, whether it's 4-20 Modbus or a contact, and then converting that into a 900 megahertz signal and sending that wirelessly back over to either a base station in a point to multipoint. So as we saw on the slide, you can have a whole bunch of them going back to one base station, or we can have a point-to-point relay system where we just take the sensor data from one sensor and send it back to the control room or the display unit. And both of those are using a 900 megahertz technology, which can communicate up to 1 mile outdoors or a half a mile indoors. And they're really robust and rugged. We do have repeaters, so if something's in the way, we can actually use a repeater to take that data around the obstacle, whether that's a tree or a building. It's very easy to do and set up. Very robust, very rugged, and we've had great success with them to date.
Is there anything else that you might recommend or suggest to plants?
Yes, one of the things we definitely would recommend is coming to your silos with the belt and suspenders approach. And what that means is having both continuous measurement for your inventory management and point level measurement for your high and low measurement points. We really think that's important in today's world. A lot of people try to skip the point level measurement because they do have that continuous measurement in there and they think that's going to take care of most of their concerns, especially in their process operation. But we think what you really should do is use the continuous level measurement to get your inventory levels and manage your inventory, and then have your point level measurement manage and control your process. So that means turning off and on pumps, conveyors, whatever your process happens to be. For a few $100 extra, you can save yourself a lot of grief in not having an overflowed bin, a plugged up conveyor, by having that point level in there along with your continuous level measurement.
I think it's clear after speaking with Scott that there are many risks and costs that are inherent in manual silo monitoring. And with the technology that's available today, why chance it? Between the time savings that comes from eliminating walking to and climbing up a silo, to the safety improvements offered in a hands-off process, silos containing liquids or solids can be left under the careful watch of sensors that can pair with Ethernet to bring the critical data to your workers wherever they are. For more information on the NCR80 from Binmaster, visit binmaster.com.